The cosmos, once a distant abstraction, now unfolds before us in detail and color that defy imagination. Like never before, we are witnesses to the raw splendor of creation itself, all thanks to a masterpiece of modern engineering, the James Webb Space Telescope. NASA has begun unveiling the full suite of images captured by this technological marvel, each one a revelation, a whisper from the depths of time. This isn't merely a leap beyond Hubble's vision. It's a redefinition of what it means to see. The James Webb isn't just a telescope. It's a time machine, a cosmic archaeologist sifting through layers of starlight to uncover secrets buried in the fabric of spacetime. Now, as the veil is lifted, we see with new eyes, and what those eyes behold is shaking the very foundations of cosmic theory. In a single image recently released by JWST, the scientific world found itself on the edge of astonishment. 6 massive galaxies, ancient and impossibly bright, shine defiantly across the black sea of the early universe. These titanic structures, once expected to be faint, formless wisps, now appear as luminous, fully developed beacons less than 1 billion years after the Big Bang. It was a moment of revelation. Theorists paused. Astrophysicists recalibrated. The very models of galaxy formation, painstakingly built over decades, began to tremble under the weight of this new cosmic evidence. How could such colossal systems, millions, perhaps billions of solar masses, have formed so rapidly, in a universe still young, hot, and chaotic? The timelines we trusted, rooted in simulations, observations and theory, suddenly seemed premature, even naive. Among the first to step into the void of uncertainty was renowned theoretical physicist Michio Kaku. A futurist fluent in both popular science and quantum complexity, Kaku interpreted the image not just through the lens of astrophysics, but as a critical fracture point in our understanding of reality itself. This isn't just about galaxies, he said. This is about rewriting the very narrative of cosmic evolution. It's where observation forces theory to kneel before evidence. Kaku pointed out that these galaxies shouldn't exist, not this early, not in this form. If our models of gravity, expansion, and structure formation hold true, then something, perhaps many things, must be missing from our equations. It was a call to action for physicists, to rethink, to question, to innovate. Central to the mystery is dark matter, the invisible scaffolding thought to support the formation of galaxies. In current lambda-cold dark matter models, it's this shadowy substance that shepherds ordinary matter together, drawing gas clouds into stars, stars into galaxies. But if these early galaxies were already massive, already luminous, and already structurally complex, then perhaps our assumptions about dark matter are flawed. Could it clump more efficiently than we believed? Could there be hidden interactions, unknown particles or exotic forces, that accelerated the process of cosmic assembly? Kaku mused that we may be brushing against the veil of a deeper layer of physics. One in which dark matter behaves not as passive scaffolding, but as an active agent in galactic evolution. The implications are staggering. Beyond dark matter lies another cornerstone of modern cosmology, inflation. This theory suggests the universe underwent a blisteringly fast expansion in the first fraction of a second after the Big Bang, flattening and homogenizing space while setting the stage for all later structure. But what if, Kaku suggests, the inflationary epoch wasn't a smooth ballooning of space, but a turbulent storm of creation, leaving behind seeds not just for stars, but for surprise itself? Equally baffling is the chemical richness of these early galaxies. JWST's spectral data suggests heavy elements, carbon, oxygen, iron, were already present in significant quantities. That means stars had formed, lived, and died with astonishing speed. The first generation of stars, known as population 3, must have formed almost immediately after the Big Bang. Burned hot and fast. And exploded in supernovae to seed the cosmos with the raw materials of life. This rapid chemical enrichment could push the timeline for habitable planets, and possibly life, further back than anyone dared to hope. Life-friendly conditions may have emerged not billions of years into cosmic history, but in its first billion. Kaku captured the emotional core of this revelation. If the universe gave birth to galaxies and stars with such urgency, what else might it have rushed into existence? Then there is the shadowy role of supermassive black holes, monsters millions to billions of times the sun's mass that often sit at galactic centers. Did such entities already exist in these infant galaxies? If so, they may have triggered starbursts, warped spacetime, and shaped the galaxies around them in a cosmic feedback loop. Moreover, these galaxies may have been rapidly fed by vast rivers of intergalactic gas, funneled in by gravity and compressed by collisions. Perhaps the early universe wasn't a calm, expanding void, but a cauldron of dynamic interactions, where galaxies fed on matter like growing flames on dry wood. Kaku suggested that the physics of ordinary matter, baryonic physics, may need a radical overhaul. Cooling rates, gas dynamics, star formation triggers, all must now be reconsidered. This moment is more than a data point. It is a reflection of human spirit, of our endless hunger to know, to see, to reach. The James Webb Space Telescope itself was a triumph of decades-long collaboration, engineering discipline, and bold vision. It is not just a machine in space, it is a symbol of what we dare to become. Kaku framed this moment as a testament to our species. We built a time machine. We looked back into the birth of everything. And what we found was unexpected. The discovery also ignites the age-old question, are we alone? If galaxies matured early, and stars formed fast, the window for life may have opened long before Earth. Ancient civilizations, lost biospheres, unknown intelligences. These are now no longer just science fiction dreams, but scientific provocations. What comes next is a period of intense investigation. More deep field surveys. More data. More comparisons. Simulations must be updated. Dark matter reimagined. Inflation reinterpreted. And as this new generation of high-resolution, multispectral telescopes rise, on Earth and in orbit, the early universe will surrender more of its secrets. Kaku predicted that within a decade, we may catalogue hundreds, perhaps thousands of early galaxies like these. And with each one, the weight of our assumptions will be tested. Some will break. Others will be reborn. This image marks a turning point. From Galileo's telescope to Hubble's deep fields, each era of astronomy has had its moment. Now, with the James Webb, a new chapter begins. One where the universe is more chaotic, more surprising, more alive than we ever imagined.